Bullet from papercartridges.com, and I'm here again at the shop in beautiful downtown Gettysburg, Pennsylvania. And today I want to talk about a question that I get asked quite a bit. Uh, why do various 19th century bullets, like the British Enfield bullet, have plugs? Sometimes they have iron cups. I get asked that quite a lot on here on YouTube, on the Facebook page, even customers coming into the shop and seeing my products. So it really is a great question, and I thought I would do a little bit of a deep dive here and explain not only why these bullets had these plugs or cups in them, but how they came to need them, why they adopted them, and also why we don't really use them today, even though that I do in most of the shooting. I do use bullets that still have wooden plugs in them. So a few days ago, I did a video on why Civil War bullets have grooves, and I thought it would be a good idea to follow up with why some of them have these plugs. So again, in this video, I want to spend a little time digging into the purpose of these plugs that were found in various rifle projectiles in the mid-19th century. And I want this video to be a preface to one I'm going to do in the future on the history of the Minié bullet itself and its distant relative, the Burton Bullet of Civil War fame. And I also want to correct the fairly widespread misconception that these plugs were not necessary. Uh, it's kind of absurd that these plugs remain the subject of some controversy. They were a little controversial even in the 19th century, but they remain controversial now. In the United States, because the U.S. rifle musket bullet, adopted in 1855, never used any sort of a plug. There's a widespread belief that us clever Americans realized that the plugs weren't needed, while those backwards Europeans still kept sticking things in the hollow base of their plugs because they're too stupid to realize that a hollow based bullet will expand itself just by the force of the gas in the barrel without a plug. And it doesn't help that the North South Skirmish Association prohibits putting anything in the base of bullets other than lubricant. So there's kind of an assumption here in the States that the ordinary rifle musket bullet never had a plug, uh, like the mini ball of the Civil War. And any kind of a bullet that does use a plug is kind of seen at best as a quaint relic or a curiosity, or at worst, it's just some stupid holdover from an antiquated time that we don't need to use today. But even in the 1850s, there was a lot of debate over the plugs from the earliest days of the military rifle musket. So we need to step back and deconstruct this essentially by answering the question, why did the military authorities in the 1850s and 1860s as well, very smart, intelligent men with the resources of their government behind them and the ability to test everything to the extent we can't approach today as enthusiasts, why did they even consider using plugs or iron cups in the first place? Well, it's all about overcoming uh, what's called windage, which is the gap between the bullet and the barrel, and the challenge of making a practical military muzzleloading rifle is to fill up that windage and make the bullet follow the twist of the rifling. It has to expand and fill the rifling grooves for it to be a rifle and for the thing to be any more effective than a smooth bore. So the goal was to find a way to get rid of the windage without the need to physically pound a bullet down the barrel like you would with like a patched round ball, so it was engraved at the muzzle. In the history of the self-expanding rifle bullet, probably something worth doing another deep dive into someday. We could start with William Greener or John Norton. But to keep this video practical length, we're going to skip all of that and we're going to jump right to this guy, a former French army officer named Henri Gustave Delvine, who is underappreciated today for his role in firearms technology. And he's best known for inventing a fairly successful primitive rifle system in the 1820s that allowed for relatively easy loading, but also getting rid of the windage. He did further experiments, and in about 1839, he made the key discovery, and that's the force of burning gunpowder alone will cause a hollow based elongated bullet to expand into the rifling grooves. In his own words, the gases produced by the burning gunpowder rush into the hollow space in the rear of my bullet, expanding it and compelling the lead to be forced into the grooves. So, in other words, no cup, no iron cup, no plug, nothing. It's just a hollow base bullet. Gas alone expands it. So remember that. This will be important later. France took the lead in rifle development, and in the 1830s, during their wars in North Africa, they needed rifles. So by the 1840s, the French had adopted a rifle, the Touvenant system, or the pillar breech, and it has a pillar in it which forces the bullet to expand by being driven down on that pillar, which is just a rod of steel that sticks out from the breech plug, often called tige rifles, which is the French word for stem or pillar. And you usually see them with a heavy ramrod, and the soldier would pour the powder, thumb in the bullet, and then he would ram the bullet down and smack it down on top of that pillar and physically expand it. And this system worked very, very well, surprisingly. And the rifles were almost as fast and easy to load as a smoothbore musket. So it was very successful. And the Touvenant rifle initially used a flat based simple bullet that had been designed like the holy trinity of uh, rifle experts in this era. You had Touvenant, you had Tamige, and this guy, Capitaine Claude Etienne Minier, who you might have heard of before. Um, so this bullet needed two stout smacks with the heavy ramrod, and that would expand it to the barrel. Once it was on the pillar, it gets forced into the rifling, and the bullet could be fired with great accuracy out to many hundreds of yards. It was a very effective concept, and it worked very well. Uh, the carabine à tige, as it was called, started to be adopted not just in France but all over the continent. Denmark and a lot of the German states very quickly realized this is an effective rifle system, quick and easy to load and accurate. But it also meant once they adopt this, everyone starts testing all sorts of variations with it in not only just the shape and length, thickness, style of the pillar, but also that of the bullet. And eventually they had the clever idea to try one of the bullets that Delvine had described back in 1839 with a simple hollow base, not the flat based original tige bullet, but with the hollow base. And it's a happy coincidental discovery that those hollow base bullets, since they already have the cavity in the base, you can just tap them down onto that pillar and they'll expand with one nudge of the ramrod rather than wailing away on the ramrod two or more strokes to expand the bullet. So it just made loading the gun a whole lot faster and simpler. And there is a little bit of irony in that these bullets are essentially identical in the shape and dimensions, both internally and externally, to the Burton mini bullet used in the American Civil War. They look, their shape, they're almost identical. So it is fair to ask, why are they still bothering with the pillar breach at all, and why are they going through all this trouble if they already know that Delvine has discovered this hollow base bullet and it's going to expand simply by the force of the gunpowder alone? Why do you need this pillar stem rod that you have to smack the bullet down onto to expand it? And the answer is kind of anticlimactic, and it's simply manufacturing capability wasn't up to it. In the first half of the 19th century, the technical manufacturing capability to mass produce rifled infantry weapons to precision tolerances did not exist. You got to keep in mind that the first micrometer, the first available tool to measure things down within fractions of a thousandth of an inch, had just been invented in the early 1840s. So skilled craftsmen could and did make precision rifles, but it cost a ton of money and took a lot of time and skilled labor. And it's impossible. So if you're France, you have a 600,000 man army. You just don't have the resources to have skilled craftsmen make precision handmade weapons with these fine tolerances. Um, so in the earliest days of modern industrial mass production, the military service rifle barrels could vary by a couple hundredths of an inch from the actual caliber that they're supposed to be. And the bullets also were produced with the same variations. Now, they would have really liked to have closer tolerances, but it just was something they had to live with. You can't make everything exactly the same in 1851. There's going to be a little bit of play in mass production. And for Delvine's hollow-based bullet to work without a pillar to expand them, they have to fit very snug in the barrel, only a couple thousandths of an inch underneath the bore size for just the force of the gas to expand them and to shoot with accuracy. And if you shoot for the NSSA or you know someone who does, you can ask a shooter and they'll confirm the most accurate shooting is done with bullets that are sized just slightly below the actual size of your barrel, like even 1,000th of an inch under bore size. And they knew this in the 1840s. Everybody knew that it would be really, really, really great if every soldier had one of these precision-made rifles with precision-made, snug-fitting bullets. But in the late 1840s, early 1850s, you just didn't have that industrial precision to manufacture the barrels and the bullets to a consistent size on a massively large scale. So it wasn't an option. So for the large European armies, you you had to make do with sloppier tolerances. Now, keep in mind, keep things in perspective. So when the French are introducing the carbine à tige, the Touvenin rifle with the pillar breech in large numbers, the U.S. is still using the model 1841 rifle, sometimes called the Mississippi rifle, and that's still using a patched round ball. So we are still forcing the bullet into the barrel with a patch. So you could, which takes a lot more time. It's not as convenient a process. So the Europeans, you could arguably say, were ahead of the United States. And even though the Touvenon or the carbine à tige pillar breech system makes up for the variations in tolerances in the barrel, it it has a couple big flaws. One of them is that pillar of steel sticking out of the breech. You can still clean the rifles; they got pretty dang good at cleaning them, but it's not convenient. Not convenient to clean a TJ rifle. And the entire system depends on the soldier himself having the cool presence of mind to ram the bullet just right, not too hard and not too soft, because if he goes on either extreme, you're either not going to expand the bullet or you're going to deform the bullet, and both of those are going to affect the flight or whether it even expands at all. So we got to go back to our friend, old Claude Etienne Minier. And in 1849, he gets, it's a brilliant idea, but it's pretty simple. So what he does is he takes the pillar out of the gun and he sticks it into the base of the bullet. And he did that in the form of an iron cup. So imagine you cut off the top of that pillar in the gun and you just stick that into the hollow base of the bullet. And now you don't need to have a pillar sticking out of the gun. When you fire it, that piece of metal in the base of the bullet, that iron cup, gets forced up with a wedging action as the gun fires, and it expands the bullet into the grooves. And so this is the Minier rifle, the Minier plain breech rifle with the iron cup. Iron Cup's doing the same function as that pillar, but instead of the soldier smacking it down on the pillar, the blast of the gun firing smacks that Iron Cup up into the cavity of the bullet. So it takes the question of whether or not you're going to expand the bullet too little or too much out of the soldier, and it puts it inherently as part of the design of the bullet itself. Minier called this Iron Cup a culot, which is the French word for the base or a bottom part of something. And we see in French documents from this early era, they're calling Minier's invention the culot tige, because it's a combination of the tige stem, and then taking the top piece off of it and putting it into the base of the bullet. Now the Minier bullets are more accurate also than the tige rifle, and the guns are cheaper. They're a lot easier to make. You don't have that pillar in it, and the Iron Cup still forced the bullet to expand a great deal. So you could mass produce the barrels, and they could vary significantly in size. But the Minier bullet, even a barrel with 20 thousandths of windage, the Minier Iron Cup could overcome that windage just by the mechanical wedge force. And it would expand the bullet enough to meet the military requirements of the 1850s. And everyone had to have Minier rifles in the first few years of the 1850s. They gave an enormous advantage. Even the old Duke of Wellington realized we need to adopt a Minier rifle. So they adopt what's called the Pattern 1851, and that used Claude Minier's Iron Cup. And these are the bullets for my Pattern 1851. Instead of an iron cup, I use a brass cup that's formed into the right shape and diameter in a press. But this is more of a Minier bullet technically than the Civil War Burton bullet, even though it doesn't really look like one. But it does have Capitaine Minier's metal cup in the base. And the P-51, the rifle worked, the ammunition worked, but the British were not really satisfied with the Minier ammunition for a number of reasons. And when they adopted the Pattern 1853 infield, they adopted a new kind of bullet with it. And viewers of my channel are probably already familiar with the Pritchett Bullet, designed by the London gunmaker Robert Taylor Pritchett. It had no iron cup, no plug, and they required a very snug fit in the barrel with about 1/1000th of an inch of windage for these bullets to expand. It was a great leap of faith in the capabilities of British industry, and it all backfired when the Crimean War began, and the demand for rifles meant that these standards could not be maintained. If the Pritchett bullet is slightly too small and the barrel of the infield is slightly too large, that Pritchett bullet is just not going to expand enough to engage the rifling. Colonel Hay from the School of Musketry launched an investigation, and he found that infield rifle barrels being issued to soldiers were often 0.003 of an inch too large, and the bullets were often being supplied 0.003 of an inch too small, and that's a fatal combination. So the Pritchett bullet without a cup or plug will not expand to fill the windage. So in 1855, as an emergency measure, that iron cup gets re-adopted, and it worked. It didn't work great. There were a lot of problems with the iron cup. So Colonel Hay proposed switching to a wedge-shaped wooden plug, and this dramatically improved the accuracy of the infield rifle, much more so than the iron cup. So the wooden plug replaces the iron cup in the English service and remained in the British service all the way until 1864, when they went to cheaper ceramic clay plugs. And if you really, really, really want to know more about British infield rifle ammunition, I got a book, The English Cartridge. You can find it on my website or on Amazon. So on this side of the Atlantic, The United States had the advantage of an emerging industry that was capable of maintaining those precision tolerances with the added benefit of having a United States Army that was about the size of a single Napoleonic infantry division. Like we 1850s, we have 16 to 18,000 soldiers in the entire United States Army. So we don't need a whole lot of rifles. Um, so when the United States adopts the first rifle musket for the U.S. Army, the Model 1855, they're only producing a few thousand of them every year. And so they are able to design a bullet to go with the Model 1855 rifle that is a very tight fit. But in this peacetime, low quantity manufacturing, only a couple thousand rifles a year, uh, we could maintain those tolerances. So the rifle was 58 caliber and the bullet is a .5775 inch. So there's barely a little over 2 thousandths of an inch of windage for the U.S. This is the Burton Bullet. Um, Everything could be gauged and measured. The bullets could be made with great precision, and it worked. The rifles were fantastically accurate. And it would be really nice if that's where the story ended. It would be a nice, clean, rah, rah, go America story, but it all fell apart in 1861. The Civil War began. You got demand through the roof for modern weapons. And in this frenzy to get weapons for armies now in the many hundreds of thousands, so you go from 16,000 men in the army to 500,000, you got to find guns for them somewhere. So both North and South go to Britain and they buy hundreds of thousands of Enfield rifles, and they came in 5.77 caliber. And so if you remember, the 5.775 US bullet will not fit in the 5.77 caliber Enfield. You can't even really push the bullet into the muzzle. So in desperation, the U.S. Ordnance Department had to reduce the size of our bullets down to 5.74 so that they would work well in the infield. But now you've got 6 thousandths of windage in the 58 caliber U.S. rifles. And so the bullets, just like the Pritchett bullet, if there's 6 thousandths of an inch of windage, without a cup, without a plug, the bullet is not going to expand. And that's exactly what happened in the American Civil War. We're in this ironic situation where we made this precision rifle designed around this precision tight-fitting bullet, and a year into the war, you can't shoot them worth a darn because the 5.74 bullets just will not expand into them. So the answer, the U.S. Ordnance Department went to figured out. You might guess it. It is a plug bullet. I have a few examples here of what we call Williams bullets or Williams patent bullets. And his concept was to take a wedge-shaped pin that would be forced into the base of the bullet when it fired, that would expand it into the barrel. It would expand it more than just a few thousandths of an inch. So it'll work in your 5.77 Enfields, it'll work in your 58 caliber Springfields, and he claimed it's going to be more accurate in both of those than the US style bullet. And initially the Ordnance Department was really excited about these. There was a attempt for a time that we're going to eventually replace the US style Burton bullet with these Williams bullets. And they ended up making 300 million of these Williams bullets over the course of the war. And so this was the second most produced bullet of the war. And more of these were made than all of the rifle bullets made in all of the Confederate arsenals combined for the duration of the war. That's how many were made. Now, the Williams bullet was very controversial. It was also more expensive. Daryl and I did a video on this a few years ago. If you go to his channel, The Ministry for History, you can see our hour-something long discussion on this bullet. But it does go to show that the U.S. government understood that a plug bullet of some kind or other is necessary if you need to get your bullets to expand in rifle barrels that are of various sizes. So if you've got 58 Springfields and 5.77 Enfields in service at the same time, a plug bullet is that one-stop shop answer. So if you can't guarantee that all your rifle barrels are going to be made with precision, um, the only way to make it work is with a plug or iron cup or the carbine à tige. You need something to force the bullet to expand. And the British in after 1859, they took this to its greatest extreme. They really tested the concept to its limits. 1859, they reduced the size of the Enfield rifle bullet to .550. Still has its wooden plug in it, and that would force the bullet to expand 27 thousandths of an inch into their 5.77 rifle barrels. And Colonel Wilford, who is a chief instructor at the British Army School of Musketry, he said it's all because of the plug. You can't make a bullet expand 27 thousandths of an inch without some aid to force it to expand. So that is why some rifle musket bullets had these cups and plugs. It doesn't make the bullet necessarily more accurate. It's really just to make them work in an era when precision manufacturing technology is in its infancy. And I still do most of my personal shooting with the Enfield rifle, and my bullets use wooden plugs. I enjoy historical shooting, which is a niche form of recreational target shooting where the focus is to shoot historic guns the way that they were shot back then when they were actually being used, and with the historic ammunition to go along with it. So that means if I want to shoot the Enfield rifle historically, I pretty much have to use a plug bullet. And this has led to some interesting experimental archaeology and the rediscovery of how quick and easy it is to load Enfield cartridges compared to like the US style Burton Bullet cartridge. Uh, so it's not necessarily that these are more accurate, like in terms of group size, but for sustained fire, because the plug expands the bullet more or less instantly, it keeps the barrel clean. It enables you to continue loading one round after another, while the Minier style bullet tends to accumulate fouling in the barrel after a number of shots. So for the plug served its purpose as a military stopgap that you can field an army that has rifles, so they're going to get the accuracy of having a rifle, but you can mass produce them with your industrial base that's not quite up to what we would call today the modern precision capability. We don't think twice now about machining barrels with tolerances of fractions of a thousandth of an inch, but that was a big deal in the 1850s. So the plug made that possible. And today we know NSSA shooters, yeah, get a rifle, mic out your barrel, and you want to size your bullets 1,000ths of an inch underneath. But if you're making 1,000,000 guns for an army at war and you can't guarantee those tolerances, you got to use a plug or the iron cup or something like that. Well, I think that's more than anyone in their right mind wanted to know about plugs or cups in Civil War era bullets. But I hope this was useful to you. And if you haven't died of boredom, you can like and subscribe. And I'll see you next time. Thanks for watching.